Analysis of simply supported beam using ANSYS Workbench. Draw the shear and bending moment diagram and determine the maximum normal stress due to bending. In this figure, we can see that we have four nodes A, B, C, D, and A and C. We are applying a load of 20 and 40 kilonewton in negative y directions, and B is simply supported, and D we have a roller support. Cross section for this one is we have 250 into 80 Young's modulus and Poisson's ratio is given. Let us analyze this beam using ANSYS Workbench. Open the ANSYS Workbench. First, static structural, engineering data, edit. Here, add a new material. So I'll take the new material as material 1. Next, the isotropic element. So I'll select like this. So the Young's modulus for this one is 210 E9. Poisson's ratio is 0.3. Okay, then close project. Now go to the geometry. In geometry, select new design modular geometry. Here we'll give the geometrical coordinates. Select XY plane. Here look at, and I am doing the entire analysis using meters, so I'll select meters here. Now zoom here. Since we can see that we are giving only one material, the entire length of the material is same, so it is very easy to draw the elements here. Okay, so 2.5, 3 and 2 meters. Now first go to sketching. In sketching line, select from here to here, and again from here to here, from again here to here, 3 lines. Now I should give the dimensions. Go to the dimensions. Now general, select like this, H1, H2 and H3. You got the 3. Now you give the dimensions, length of the 3 elements. Now first one is 2.5, 3 and 2. First one is 2.5. Next is 3 and third one is, so 2.5, 3, 2. 2.5, 3, 2. Okay. Now it has been completed. Now give generate. After this, you should go to the concepts, line from sketches, select first line, control, second line, control, third line, give apply, then give generate. Now it is completed. Now we should give the cross section. So go to the concept, cross section is a rectangular cross section. The width of this one, the rectangular cross section B is taken as, it is in mm, as I'm doing my calculations in meter, so convert it into meter. So we'll get 0.25. 0.25. B is 0.25 and H is, it is 80 mm. Convert this one, you'll get 0.08. 0.08 meter. So this is the height. So that we are given the breadth and height, then give generate. After this, we can see that one part and one body is created. Select here and again right click here. So now cross section, you are given the rectangular, select rectangular one and give generate. So that second step is completed. If you want to see the view of this one, whether it is rectangular section, go to the view. In view, we can see a cross section solids. You can see the cross section solids, and if you want to this, you can revolve this one. So you have to revolve. Go to the revolve option. So we can see the cross section of the rectangle. After this step is completed. Next, we'll go for the modeling. In a modeling, go to the edit option. Next is in a modeling, we have to give the geometry since we have created a new material here. Here you select geometry. In geometry line body, we should select the assignment as material 1. Okay. After this step, we have to do the meshing. Go to the mesh, right click meshing, generate mesh. So we can see here the beam element is meshed. After this step, we have to apply the boundary conditions. So go to the static structural. In a static structural, we have here, we can see that we have to see the cross section. We can select the display here. Display, select cross section. So you can see the beam element here. After this, we have to apply the different boundary conditions. Now see the figure. The first node, we are applying a load of 20 kilonewton in negative y direction, and the B, node B is a fixed support, simply supported, and C is we are applying a load of 40 kilonewton, and D is a roller support. Now I'll apply the boundary conditions. Here the I apply the first fixed support. Go to the environment. In environment, here we have a support. Since it is simply supported, select simply supported. I'm applying the simply supported at node number 2. So in node number 2, go to the vertex, select vertex, and give your apply. So you can see that the node number 2 is simply supported. Now I have to apply the roller support at node number 4. So go to node number 4. In ANSYS Workbench, the roller support is given by remote displacement. Select remote displacement, and you can see that in the figure, the roller support is in y direction here, so that the y direction it will not move freely, and in z direction it will not move freely. Only it will move freely in the x direction and rotation of z. Okay, so now I'll apply that x component. It will move free, whereas y it is 0, and in z it is 0, and also rotation of x is 0, rotation of y is 0, x is 0, y is 0, and it will move only freely in z. Rotation of z, it will move freely, as well as the in case of x. So now select z component, it will be move free, as well as the rotation of, you can see here the x component is moving free, y 0, z 0, rotation of x 0, rotation of y 0, and rotation of z is moving freely. Okay, now select the vertex and give apply, so that you can see that roller support is been applied. Now apply the two boundary condition. One is the simply supported at node number 2, and roller support at the last node. Now I should apply the load. So now you can see that in the first node I am applying a 20 kilonewton in negative y direction. So now go to the model here. Again I'll go to the force. Again I should select the vertex. I'm applying the first vertex. Now select the vector to change it to components. You're applying the negative y direction. Negative y direction, I'm applying the load of 20 kilonewton. So it is minus 20,000. Minus 20 E3. Minus 20 E3. Now give apply. So you can see that at the node number 1, the load is applied in negative y direction of 220 kilonewton. Now at node number 3, I should apply 40 kilonewton. Similarly, go to the node number 3. Node number 3 is a force. Again go to the components. It is minus 40 E3. Minus 40 E3. Vertex. Now give apply, so that you can see that here if you want to see all the boundary conditions, the first is simply the first node is you are applying the 20,000 Newton, and second node it is simply supported, and the third node you are applying a load of 40,000 Newton, and at the fourth node we are applying roller support. Now all the boundary conditions is done. Now I should do the solution. Now go to static structural. Same in static structural, insert. Before that I'll solve this. Static structural, right click, solve. Solve. Now the command is solved. Now go to static structural, insert, solution, insert. In insert, you should go for the deformation. In deformation, select directional deformation. In directional deformation, always the orientation is takes place in beams in y-axis. So select y-axis here. Okay, now directional deformation is done. Now I want to determine the stress. Go to the solution, insert beam tool. In a beam tool, here we can determine the different stresses, direct stress, minimum stress as well as the maximum stress. We'll get the different stress conditions here. If we, the main intention of solving the beam problems is to determine the shear force and bending moment diagram. So now here, the solution, right click, insert beam results, shear moment diagram. If you want to draw the shear moment diagram, the first important thing, you have to give a path. So what we should do is we should do an extra step. Select model, right click. In a model, right click, we have insert construction geometry. Construction geometry. Okay, so we have to go for the construction geometry path. In a path, you should select the edges. Here you can see that path type is there. We have to select this as edge. Now edge. Now we have to select the edges here. Select edge number 1, control. Edge number 2, control. Edge number 3, control. Now give apply. So we can see that now the path is created from 1 to 2. After these conditions, now you go for the solution. In a solution, you can see that shear moment diagram. Here you have to change this path to again path, and here in a type you should determine the directional stress in the y direction. Select this one. Now go to solution, evaluate all results. Now yes, done. Now we can see that direct stress, minimum stress, as well as the maximum stress. Now if you want to see the cross section of this one, now go to the display, go for the I sections. Now we can see that here the maximum stress minus 9.7 10 to the power of minus 8, minimum stress is minus 6 into 10 to the power of 7, minimum stress. Okay, if you want to see the directional deformation, this is the directional deformation. Maximum is 0.003, it's a maximum in meter, and minimum is minus 0.007. And if you want to see the bending moment and shear force diagram also, you can see here. Okay, this is the final solution for the given beam element. Okay, this is the starting maximum combined stress, minimum combined stress, direct stress, direct directional shear moment diagram, and we have the, if you want to see the entire in Excel sheet, so you can go to the right click solution, worksheet result summary. So you can see here what is the minimum and maximum values of this.